Hey folks, today I'm going to walk you through how to use multi-sub optimizer to optimize and integrate multiple subwoofers in your home theater. This is a piece of software written by Andy over at DIYaudioengineering.org. He writes this himself, makes it available for free for people to use. It's a great tool. It's meant to complement a lot of the different things that we already use in our home theaters, like REW, which I think a lot of people are used to using REW with the miniDSP to optimize their subs. I think one of the big differences and one of the big benefits of multi-sub optimizer is that not only does it optimize your sub performance for your main listening position, but it can also optimize the sub performance in the non-main listening position seats. So, we're going to be using my home theater as an example. I've got three listening positions. We got a big couch with a main position, a center, in the middle of the couch, a left position, and a right position. But you're really only limited by the number of measurements that you take. So if you've got four seats in a row, or you've got multiple rows, it's just a matter of taking more measurements and then letting MSO chew on the results to get you some better performing subs in your theater. So with that, we're going to go ahead and jump into things. So what are we going to do today? Well, an overview of the process is here, kind of on the screen, right? So we're not actually going to take some measurements. I've got measurements that I've already taken. There are some guidelines provided by Andy in the MSO documentation online that are probably a little bit different from what you're used to. I may do a separate video on taking measurements specifically for use with MSO, but I'm just going to use some measurements that I've already taken. We're going to export those measurements just as some text files, which is then going to let us import them for use in MSO and set up our configuration in MSO. We'll set up two different configs. We're going to set up a baseline, and then what a config we'll just call optimize. It's going to show the output of our optimization. We'll show you how to set up a comparison graph to compare the before and after, and then also compare different iterations of optimization, because you're probably not going to you may not get the results that you expect the first time you run it through. You may want to tweak some things after you see the results. And we're just going to run through one or two examples of that today, but I'll give you some ideas on things to change and things to consider when you're trying to optimize later on. We'll review and kind of compare the results against the baseline. We'll run, like I said, we'll run run through some options for improving the results. We'll run another optimization, and then I'll show you how to compare the results, not just by eyeballing the graphs, but also by using some of the performance metrics that are included as part of the MSO functionality. So with that, let's jump in and go ahead and get started. So, as mentioned, the first thing we need to do is we need to get some measurements from REW, and we need to get those into a text format so that we can import them into MSO. So as I said earlier, I've got some measurements I've already taken. Everyone should be familiar with REW. There's a ton of different tutorials out there on how to use it, so I'm not going to go into that today. I highly recommend a lot of the resources that are out there, particularly AustinJerry's guide to getting started with REW, which is available in his signature over on AVS forums. There is another person, Enrico Claudio, who happens to work for Rhythmic Subs, who created a similar guide for those of you that use REW on the Mac. I'm actually a Mac user. I'm doing all this work on a virtual machine up in AWS. So forgive me if I mess up a few clicks here and there, just being a Mac guy. So first thing we're going to do is just open up some measurements that I've got saved. So I've got this set of measurements that I'm going to open up that I took in my theater a while back, excuse me, when I was working to get my subs aligned with MSO. So we'll open that up and we'll see everything pop up here on the display. And I want to talk about we'll talk about how to take these measurements in a different video. But there's some important things that we want to do around getting these set up for export. So the first thing that we want is we want to make sure that we have one measurement per sub per location. So if I mentioned earlier, I've got a couch with three positions. So I have three different positions that I need to take measurements. and I need a measurement for an individual measurement for each sub at each of those positions. So I have 4 subs in my theater, so that's 3 positions times 4 subs means I'm going to have 12 measurements that I export into text so that I can use in MSO. We don't want any extra measurements whatsoever. If you look over here on the left, you'll see I've kind of got I was playing with some trace arithmetic just to kind of look at what some of the combined responses might look like. And I've got 3 of those in here that I want to remove. So you can see I've got an MLP 12 hertz raw. I've got a right 12 hertz raw and a left 12 hertz raw. I don't want those in MSO. I just want my sub responses. So I'm going to go ahead and just remove those. And you'll see the SPL lines, so those disappear up there at the top. So now I've got just my 12 measurements. The next important thing, and this is not that it makes anything, it's not gonna break anything, but it's gonna make your life a lot easier, is let's talk about how we want to name each of these different measurement traces. You can see the way that I have these named is based off of the listening position. It might be a little bit hard to see, but it's the listening position and then a dash and then the name of the sub. So I have an MLP listening position, and then each one of my subs has its own measurement. So I have a left front, a right front, a left rear, and a right rear. You can have your positions named anything you want. You can have your subs named anything you want. What you want to make sure to do is to keep the sub names consistent across all of your positions, and make sure that you have each of your positions names consistent. So we can see all the way through MLP, left front, left rear, right position, left front, left rear, right rear. And then the same for the left. The order doesn't matter here on the left, because this is what these names are going to do is these are going to be the file names that get output. So you'll see, for example, an MLP -lf.txt file, and that's going to make importing things into MSO much easier for you later. So let's go ahead and export these. So what we go do is we'll click on File up here at the top, and then there is an export option. And the second option down for export is export all the measurements as text. So we're going to go ahead and click that, and it's going to bring up a window on export settings. These measurements were taken from 10 to 300 hertz. That's a recommendation for some of the MSO guidelines per Andy. So I've used that range. I'm using the default resolution from REW. One of the things that we want to override is if you're doing this for the first time, it's going to say use the smoothing of the measurement. I don't have any smoothing on these, but I always like to force this to say, hey, use custom smoothing and make sure that there is no smoothing whatsoever on any of your measurements that you're going to export. This REW format is just fine. It'll give you a preview of everything down here. Text extension, all the other things are fine to keep as the defaults, should be fine as the defaults. And we just want to make sure that we're forced no smoothing on all of our measurements. So when we go down here and we click OK, it's going to say, hey, where do you want to save these? I've got a little folder set up for this up on the desktop. So I have this MSO folder. I'm going to right click, I'm going to create a new folder, and I'm just going to call it my export. All right. We'll click on that, and then we're going to say save. And this is going to go ahead and export things. It's really fast, really quick. These files are pretty small. And we can see here in Windows Explorer that I have this export folder. And if I drill into this export folder, as I showed you earlier, all of those files have been exported with the name of the measurement trace that they had in REW. It's going to make our lives a lot easier. That's really all there is to it to get your measurements out of REW and ready for use in MS. So now that we have our measurements exported, we can go ahead and get this stuff out of the way. We can close REW. Now we need to import our measurements and configure MSO to do the optimization. Okay, so again, I'm using a pre-released version of MSO. It looks identical to the current version that's out there. This version is going to be released pretty soon by Andy. I know he's got a few things that he's been working on. There's a huge rewrite of the tutorial that's based on the new functionality that he's added. So we'll walk through a little bit of that. I'm going to use that new functionality to kind of show you how to do this. Just really quick, if you're not familiar with MSO, you've got a data view column over here on the left that actually has two tabs. There's a data view tab at the bottom. This is where we're going to use to look at graphs to compare our results. And there's also this config view. And you can think of a configuration, each configuration, we're going to use multiples here. Each configuration is like a unique test or a unique optimization that you want to run. So what's really nice is I can have a baseline, I can have as many different tests or as many different configurations that I can flip back and forth and compare with until I get the results that I want. And it makes it very, very easy for us to see how we're improving and how we're changing things. Here at the bottom of the screen, we have an output section. When the optimization is running, you're going to see a bunch of stuff scrolling through here with a number that we're going to talk about later that represents how optimized or how good the results are. We'll also look at some of the graph cursor data. This big gray area in the middle is where our graphs are going to show, and we can right click on that and kind of show the data, the frequencies and the SPL values and such. And actually get the values here, which is really nice. And on the right hand side, we have this properties tab. This is really useful for displaying the values and the settings that we have for various filters on our channels that we're going to use to optimize our subs. Okay, so that's the quick intro, just kind of what the UI looks like. So now let's go ahead and step into importing our measurements and getting MSO configured for an optimization. Okay, so as I mentioned, we're using a pre-release version of MSO, and one of the things that's been added are a pair of import wizards, and these greatly simplify getting MSO set up and ready to optimize your subs. I think the learning curve for doing a lot of this stuff manually was probably the biggest barrier that folks had to getting to know and getting to learn to use MSO. And this version that Andy's got coming really simplifies that with the wizard. Basically 90% of the work is really, or more actually, has been done for you with the wizards. So if we go here to file at the top, down at about the middle of the file, in this middle section here, there's this measurement import wizard that we're gonna start with. So let's go ahead and click on that, and it's going to ask what kind of data that we're going to be importing. MSO can do a couple of different types of optimizations. One is a sub-only optimization, and then the other one is a sub and main speaker optimization. The sub and main speaker optimization can be used to not only optimize your subs to work well together, but also to optimize their integration with either your left and right speakers, your mains, or your center channel. We're not going to get into that today. We're just going to walk through a sub-only configuration. If I get the motivation, perhaps I'll walk through a sub and main speaker data integration as well, but we're just going to do a sub-only optimization today. So if you go ahead and hit next, it's going to say, hey, what measurements do you want to import? So we're going to click add files, and then we're going to go find where I exported or where you saved those files that we exported from MSO. And here you can see just exported a few minutes ago based on the timestamp of the system. These are all the files that we just exported from REW. So if you click the first one, and if you go down to the bottom one and you hold the shift key and click the last one, that'll select all of those files at once. And you can say open, and they're all going to appear here. There should be 12 of them, which there are. And then we'll go ahead and we'll click next. And it's going to ask you if you want to either just import the measurements or if you want to run the configuration wizard. We're going to go ahead and run the configuration wizard because this is the piece that really simplifies our lives as MSO users. So if you click finish, it's going to run through the import, which is pretty quick. And it's going to start the configuration wizard immediately on import. And it's going to ask us a couple of questions. So the first thing we want to know is it's made some guesses on how many subs and how many listening positions that we've got. So we just want to verify these numbers and make any corrections to our counts here. So as I mentioned earlier, I do have 4 subs in my config. If you have 2 subs, if you have 6 subs, whatever you've got, you can enter in the number of subs for which you've got independent measurements here. The next one is, hey, how many listening positions have you measured? I mentioned earlier I've got 3. If you did 4 or 6 or 9 or whatever you did in your theater to import into MSO, let's make sure that you've got those in there. The most important thing is these are how many measurements we've imported. So for example, if you've only, if you're running through this with test data and you've only done the first row of your theater and you've only got 12 measurements, make sure you've got 3 seats and 4 subs, or if you've got 8 measurements, maybe you've got 4 seats and 2 subs. Just make sure that this corresponds to the number of measurements that you've actually taken and imported. Go ahead and hit next. And now it's going to ask, hey, what are the names of your subwoofers? It's just got them listed as 1, 2, 3, and 4. That's great if that's what you call your subs. That's not what I call my subs. It's not super intuitive for me. So you can go ahead and actually edit this and give your subs proper names. So if you click on a sub and then you hit F2, it'll let you change the name of it. And I'm just going to match the names that I used in REW because that's how I think of them in my theater. So I have a left front sub. Click on the next one here. I have a right front sub. I'll click on the next one. I have a left rear sub. And then I also have a right rear sub. So those are my sub names: left front, left rear, right rear. Make sure they mean something to you whenever you input yours. And then we get to do the same thing for our listening positions. So as I mentioned, I've got a 3-position couch. I've got a left position that I'm going to use. I've got a main listening position in MLP. You could call it center. You can call it Steve, whatever makes sense to you. And then I've got a right listening position. So I've got my positions in here named. And again, that was click on it and then hit F2 to make the change. It's the same for the subs as it is for the listening positions, and go ahead and hit next. And what we're presented with is a nice little matrix. The matrix here has our custom position names, left, MLP, and right, and our custom sub names listed out underneath each one. So I've got a left front, left rear, right rear. I've got the same for my MLP and the same for my right listening position. And what we're going to do here is we're going to associate a measurement file with a position in our theater, right? So if we click this little drop down on the right-hand side, it's going to show all of the text files that we've got. And remember when I told you want to name these something in REW that makes sense because it's going to make our lives easier? This is where it makes our lives easier. If these are just called, for example, 1 through 12, you're not going to know what's what. And it's really, really important to make sure that you have the proper measurement associated with the proper sub at the proper position. So for each one of these, we're just going to go through and we're going to select which sub matches up with which measurement for each of these. Right rear. So now I'm on MLP, left front, MLP, left rear, right front rather, and right rear. And the same thing for left front, left rear, right front, and right rear. If you've gone through this and accidentally selected a file twice, it'll throw up a little error message that says, hey, you've got the same measurement selected 2 times. Go and double check that. Again, make sure that these are correct. This is pretty important. If you have something that's associated incorrectly, like you have 2 different subs swapped in the position as they're associated here, your results are going to be completely invalid, right? So we want to make sure that these are mapped correctly. Once those are mapped, go ahead and click next. It's going to create a template. We're not going to go into templates right now. Templates are used for creating configs really, really quickly from scratch. We're just going to leave this. We'll just call it subtemplate 1 so we can accept the defaults right here. And we're going to give this config a name. Now, I always like to use an initial config that's called baseline because that gives me something that I can always return to, that I always know is going to be my basis for comparison for my starting point. We're also not actually going to make any changes to baseline. So it makes it easy for us to also, just like using the template, it makes it easy for us to duplicate our config later. So the next thing we need to specify is how many PEQs, how many parametric EQ filters we want to use per sub. This is going to vary or can vary depending on the hardware that you have. I think the vast majority of people are using a miniDSP 2x4 HD. That's what I personally use. That's what I highly recommend you use. The HD has a better processor in it. And as a result of that better processor, it supports a lot more filters than some of the other models like the standard 2x4. If I remember correctly, the HD will support up to 10 filters on the input channels and 10 filters on the output channels for PEQ. Where do we start with this number? So I know I have 10 available. I don't really want to use all 10 initially because I may not need all 10. I personally tend to start with half the number of filters that I've got available. This is just my personal thing. You could start with 4, you could put all 10 in there. It really doesn't matter. The reason I like to start with half is because I want to see where my optimization kind of gets initially. And then I can add additional PEQs, or I can add more PEQs if I want to target certain things within the range that we're going to optimize. So we'll talk about that optimization range here in just a little bit. We're going to use, for the miniDSP 2x4 HD, we're going to use the RBJ-Q definition. If you're using other hardware for your subs, like Behringer iNuke or some other non-miniDSP hardware, you may need to use this legacy definition. The help file here in the little pop-up kind of walks through why. If you're not using a miniDSP 2x4 HD, go check the documentation and understand when you should be using this. The rest of this stuff we're going to leave checked. So we want to add gain blocks to control the gain of our subs. We want delay blocks on all of our subs. And we want to go ahead and have it create a graph for us and launch the graph properties when we're done. And then we're going to launch the optimization options when we're done as well. So let's go ahead and hit finish. And it's going to create a bunch of stuff for us. The first thing that we've got is we have an initial graph of the sub responses at each listening position. So I've got 3 charts here, or three SPO graphs rather, response graphs. One for the left in blue, the MLP is in red, and the right side is in black. And again, this is my actual data. So I want to change the title of this graph before I do anything. So this is going to be the title that actually appears here. So I'm just going to call this baseline, baseline, if no one can type when everybody else is watching, right? Baseline listening position responses. If you hit apply, it'll change it on the fly, but leave this open, which is great. I want to make a few small changes on the axis as well. The first thing that we want to do is this is fine, I think, for most people. I do tend to optimize a little bit lower because my subs have a lower frequency response. So I'll optimize down to, maybe you'll choose 15 hertz, maybe you'll choose, 12 hertz, just kind of where your subs are responsive to. I actually implement a high pass filter to kind of protect my subs. So I'm going to look at things from 18 hertz to 150 hertz. Actually, let's leave it at 200. That's fine. And we'll go ahead and hit apply. Now let's take it down. Let's just look at it bigger. That'll be fine. We'll go to 10 hertz. So there we can see my response down to 10 hertz on my subs. The y-axis, I always like to change this a little bit. First of all, you can see that this kind of pops up to about 105. And I want to try to get this a little bit closer to what I'm used to seeing in REW, which is a 5 dB scale. The responses here are going to look pretty different because it'll automatically change this scale. So I'm going to change this. And I'm going to give myself a little bit of room because we're going to separate some graphs here in a minute. and we want to leave room so that we can have multiple charts on the same graph. So this is going to give us some consistency, right? So I'm going to change this to 40 and 110. And that's really all we need to do on this graph for now. So let's go ahead and hit OK. And if you remember, we had a checkbox on the optimization options as well. We'll walk through this real quickly, but we'll get into it. I'm just going to walk this through from what the settings look like. And then when we get into a config, we'll talk about the different values that we're going to use. So it is best practice to just use the minimize seat-to-seat variation. Some of these others are used only if you're doing a mains integration, which is why these options are grayed out. We can talk about the criteria. The criteria is where we specify the range that we actually care about, optimizing in our environment. I'm going to go ahead and change this right now, and we're going to change this to, because I want this to flow to my other configs. I'm going to change this now, and we're going to go ahead and optimize from 15 to 150 hertz. I tend to, you could go up to 160. They'll say that the best practice would be, what's the highest frequency that you plan to use or you think you might use for a crossover, and then go an octave above that. And the reason is that crossovers are not a cliff. Crossovers have a slope depending on the actual slope that your AVR or your room correction software uses. So that's the recommendation. So if you think, hey, 80 hertz is probably what I'll end up using, or something around 80 hertz, maybe you want to take this up to 160. If you're going to do something like 100 hertz because you have some smaller speakers that don't play quite as deep, maybe you take that up to up to 200 hertz, right? So this next bit down here at the bottom is how long you want to run the optimization. For lack of a better term, MSO essentially brute forces the optimization parameters. So it computes the different delay combinations, the different parametric EQ combinations over and over and over again. And it'll run for as long as you let it run. So if you told it to run here for 300 minutes, it's going to sit out there and it's going to churn for 300 minutes. But what you'll see is there's usually a little bit of a diminishing point of returns. We don't want to spend, too much time sitting there waiting. Personally, I mentioned I'm running this in a VM. It's actually up in AWS. So I'm paying for compute on these things. So we're going to leave this. You can leave this as it is, depending on where you're running it. I'm going to add some consistency to this. I'm not going to run anything longer than 20 minutes. And I'm going to cut the optimizations out of the video so you can just kind of see the before and after. But we'll run everything for 20 minutes for the purposes of the video. This next one, PEQ parameter limits. This sets the parameters for the individual PEQ filters on each sub. So what we want, there's a few things that we want to tweak in here. We'll go into some of these in a minute because some of these, particularly this, particularly the maximum cut items and then the constraints that are related to these on the next page, are kind of dependent on this reference level that we're going to talk about here in a few minutes. So the important thing to know is that if your criteria is from 15 to 160 hertz, which is what I've done here, you want your parameter limits for your center frequencies to match that. Okay, we don't want to accidentally limit where our center frequencies for our filters can be placed to something that's less than our optimization range. And we also don't want it optimizing stuff outside of our optimization range. So make sure your PEQ limits are set to the same thing as your optimization range. Excuse me. We'll get into the maximum cut and maximum boost here in a minute. Typically, there's no reason to change the min and max Q, but you might need to change this just depending on some of the limitations that you might have in your particular DSP platform. Constraints. This is something that we'll talk about in a few minutes. This is used to help us limit the effect of stacking PEQs. So one thing that can happen is you can end up with multiple filters that have the same center frequency, but different gain or cut values. And for example, you can see in my graph here for my response, hey, I've got a pretty big peak for a lot of this at about 25 hertz. Well, maybe it puts a narrow filter here for something, but then it puts a really wide filter here to take all of this stuff down. Those multiple cuts can end up stacking, and you can end up with really odd dips and really odd performance once it's implemented. So we'll talk about how we can limit that. We are not going to use a target curve, and that might be a little heretic for folks that are used to doing your optimizations for a single position with something like REW. What we want to do is we want to decouple our target curve from our sub alignment. Most room equalization platforms, Odyssey, Dirac, which is what I use, Anthem's ARC, all allow you to specify a target curve within the Room EQ software. So that's what we really want to do, because that lets us change our Room EQ and change our target curve without having to go back and recalculate and potentially realign and mess up our sub alignment once that's done. So we're always going to EQ to flat within MSO. If you start going through some of the documentation that Andy has out there for MSO, he does a much better job of explaining why we want to decouple these things. But I can also show you a few different ways to set up a house curve. The one that I've used in the past with Yamaha's YPAO in particular, that make things really, really easy to implement. All right. And then the last bit on here is group weights. We don't need to worry about this. These really only come into play if you're using the as flat as possible method, which we're not going to use. So we'll go ahead and we'll click OK. So we've just completed our initial measurement import and our config wizard. So if we kind of go back to our little checkbox, we've gone through steps 1 and 2, and we've actually kind of gone through part of step 3 because we named our config baseline when it first came in. Now let's take a quick look and see what what are the actual results of that. We've been looking at this graph here that we named as part of our import. On the left-hand side, if you click on data view, you're going to see that we have some information here now. We have our measurements for our subs. If you double click on one of these, I thought it would actually show you the measurements. Yeah, there we go. Right click and it'll show the imported text. You can actually see what we got brought in. Really nothing to do with these measurements, so I typically just minimize that. And then here we can see our graphs, right? We'll be creating multiple graphs, and we'll get into renaming graphs and renaming traces so that we understand what we're actually looking at, and it shows up properly in our graph scale down here at the bottom. But the one that's more interesting to me, and this is kind of where the wizard really helps out a ton, is on this config view down here at the bottom. At the top, we see configurations, and notice, remember, we called this config baseline when we imported it. So if we expand baseline, we're going to see a bunch of information out there. If you remember, we have 3 listening positions and we have 4 subs. So if we look down here on our subwoofer channels, we see I'm going to have a channel for each sub. I have a left front, I have a left rear, I have a right front, and I have a right rear. That corresponds to the names of my different subs. When we did the import, when we did the configuration wizard, we also said, hey, I want 5 PEQs per channel. I also want gain and delay blocks. So if we look at each one of these things, we can see under each channel, there's a filters folder, and I can see I've got 5 PEQs, a gain block, and a delay block. And these are the things that we're telling MSO, hey, you have these things to work with when you're trying to get me a good sub response, okay? As far as our listening positions go, those are part of the optimization parameters, and they get put into something called measurement groups. This is where we associate our different measurements, our different sub measurements with each listening position. So what we're looking at on the right-hand side in this particular graph are the results of these measurements that are summed from REW within MSO. What's interesting is if you go into REW and you use the trace arithmetic function and you add all of these together, the charts are going to be exactly the same as what you have here in MSO, right? So that just kind of shows you, you know, how this data gets imported, and then it's the same stuff that we brought in. All right. So our next step that we want to do is, I personally, again, this is how I use it, is I don't like making any changes to my baseline configuration. I always want to keep, whoops, I double clicked on that. I always want to keep my baseline configuration vanilla. I don't want to change anything on it or tweak anything on it. So I want to create a configuration that we're actually going to use to run an optimization. And that's where we're going to go in and talk about some of these measurements and some of the optimization parameters that we kind of glossed over a few minutes ago. So the cool thing about this, and this is one of the really powerful things about MSO, is it's really, frankly, pretty trivial to duplicate our configurations. So if I right click on baseline, you're going to see down here about the third or fourth one, third section at the very top, there's a clone configuration. So we're going to go ahead and select clone configuration, and it's going to pop up a dialog, and we're going to give this thing a name. Let's call this, you know, I think Andy calls them iteration 1 in his demo. I'm just going to call this optimization. We'll call this optimization 1. I usually use much more descriptive names for my configs. So, you know, I might put something like the target level. So maybe we'll optimize for we'll just use the basic default config. Maybe this is going to be a 75 dB, and we're optimizing from 15 to 160 hertz with 5 PEQs. The reason I like to do this is because as you start getting more and more configurations, it becomes really, really easy to lose track of which configuration is what without having to drill in and look at each configuration option that you have. So this just gives me a little bit of a better idea of what's out there. And we are going to go ahead and clone the associated graphs. So let's go ahead and say okay, and we'll see that we've got a new configuration out here right below our baseline, and it's called 75 dB is the name that I gave it. And if we expand that, it's going to look exactly like our baseline config, which is what we want. If we go to the bottom left and we click the data view, we can see we've got a new graph as well. We said, hey, go ahead and clone the graphs as well. So if I right click on it, I say show, the first thing I want to do is I want to rename this graph. I want to clean up this name. So let's get rid of the this copy of baseline bit, and we're just going to call this my 5. This is my 75 dB PEQ, 5 PEQ rather, listening position graph. I want to make one more change to this. So I want to right click. I want to go to graph properties, and I want to change this name here because it cloned it for us earlier. So I'm going to call this a 75 dB -15 to 165 PEQ listening position responses. We'll say apply. Now, one of the cool tricks about cloning configs is if I go down to data, the data that we're graphing is those measurement groups that I showed you earlier on the config. When we clone it, it automatically selects the proper measurement groups for this graph. So we don't have to go in and actually change any of this. I'll show you in a minute how to create a custom kind of before and after graph so you can see what things look like, both obviously before and after, but also while the optimization is running. So we'll go ahead and say, okay. Now, if I right click on this and I say, hey, let's go ahead and show my graph. There's my new graph. It's got the new name. It shows the proper name up at the top of the toolbar, and it shows the proper name for the graph title. If we flip back and forth, by selecting the proper tab. Come on. Oh, there it goes. It actually will, the graphs are going to be identical, right? So it's just the title changing because we haven't done anything yet. So the next thing that we want to do is I want to create a graph from scratch that's going to give me a nice before and after view of our optimization before we run it. So if we go on the left-hand side, We select graphs. If we right click on this one, we can see new graph. So we'll go ahead and say, let's create a new graph. Our data, remember, is going to be from measurement groups. Okay. We want our baseline positions and we want our optimization positions. So let's just go ahead and we're going to select all of these and we're going to say apply. And we're going to get this graph that pops up here. So that's got our data in it. This is going to be our before, which is our baseline, and our after, which is our 75 dB here that we're doing. Now I want to go ahead and tweak some of this. So I'm going to call this graph before and after. I want to show the legend so that we know what's what. We'll click apply. Let's go make the same axis tweaks that we made earlier. I think I went down to 15 hertz, or maybe I went down to 10 on my graph. I don't remember off the top of my head. My y-axis, we're going to make that the same 40 and 110 that we did earlier. We'll say apply. So now I've got a nicely formatted graph here that we can look at. So when we create graphs, it doesn't by default know really what to name things. So the first thing we're going to do is let's go ahead and change the graph name here on the left-hand side. Right click, rename the graph. We're going to call this before and after. So now that changes our tab name up here at the top so that we can see the proper thing we're looking at. If I expand this, it's going to show me the data that it's actually graphing, but these aren't really descriptive. So what I can do is if I click the plus sign next to one of these, I can see the configuration and the group that's actually being optimized. So now I can easily go in and rename each one of these channels so that it's more descriptive and we know what we're looking at. So if I right click, I can rename it. I'm just going to call this base. I'll call this base left. If I expand the next one, rename it, this is going to be my base MLP. And you can see as we make these changes on the left, it's changing our legend at the bottom of our graph. Expand this one. This should be my little bit of a lag. Sorry. There we go. So if I expand this one, this is going to be my base right. And here we can see the other ones. I'm just going to call this one, I'm going to call this one 5 PEQ left. This one should be MLP, and then the bottom one should be right. So we'll call it 5 PEQ MLP. And then we'll call this one 5 PEQ right. So now everything is named. Problem is that everything is on top of itself. We want to be able to clearly see which, we want to be able to clearly see our optimization as it's running. So what we can do is we can actually offset the optimization graphs that we're going to run. So if I right click on one of these and I go to properties, magnitude display offset in decibels. So here I can say, okay, how far offset do I want this to be from where I'm actually running it? You can pick whatever you want. You just want to get it kind of sufficiently below the graphs that are up there. So it looks like, I think we're going to run this one at 75 dB. So that's going to put it kind of right here kind of in this middle, which is still going to overlap a little bit. So if we're going to optimize at 75 dB, and I want to get it clear, let me just drop this off by another 10 dB. So if I say apply, you'll see it's going to drop it down by 10 dB, and we'll do that for each one of our graphs. Properties, set it to -10. We'll apply, and for our last one, properties, let's set this guy to -10 and apply. Cool. So they're all overlapping quite a bit, but remember we're going to optimize for 75 dB, and the offset is from that optimization. Target. So they're actually going to end up centered somewhere around 65 dB, which is way down here. So there's going to be plenty of room for us to see what our optimization is doing, and have that clear of our baseline response graphs. So we've got a nice before and after chart ready to go. What we now need to do is we need to get into some of the nitty-gritty on our optimization options and actually run the optimization itself. Okay, so now let's dive in and really set our optimization options for this particular configuration. So if you click down on the bottom on the left-hand side, let's go from the data view to the config view. And once we click on the config view, you can see we've got our baseline config here at the top, and we've got our 75 DEB or 75 dB config here that we're going to actually optimize. So if we right click on this, let's go down to the second one, which is optimization options. And this is going to bring up that optimization wizard that was brought up initially as part of the configuration. So as mentioned, we're going to optimize this. We're going to using minimizing seat to seat variation. We're going to use a 75 dB reference level. Now, when we talk about how do we figure out what our reference level is supposed to be? Well, the easiest way to do that, I'm going to cancel out of this real quick, is if we go look at our baseline listening positions, it's really a judgment call. And what we want to do is we want to avoid having to do any boosting of frequencies. Yes, you can do boosting. In my own personal config, I do allow, I think a 3 dB boost for any particular PEQ. Generally speaking, boosts are we want to keep those to a minimum, right? Because we can end up introducing noise into our optimization and into our config, and we don't want to do that. We're going to end up removing headroom that we want to keep for performance. But overall, we just want to kind of eyeball this. So if I kind of look at these measurements here, everything's playing pretty nicely together. Up until about 50 hertz is when things really kind of start to go haywire in my particular room. That's going to vary for your particular room. And then, you can see everything kind of comes together. Maybe is that around 115 hertz or so. So this is where we want to kind of look and get an idea for where we want to optimize. So some of this is going to come up naturally just by aligning our subs. If I look over here, there's the 75 dB target line. It's really below all of the big dips that I've got in my particular room. So that's probably a pretty safe place to start. When we talk about improving the results that we see, one of the things that we can do is run the optimization with the same exact parameters, but with different target levels. I recently helped out someone over on AVS Forum, optimize their subs with MSO. And we started out, again, the same way I did. Hey, 75 dB. I don't remember what his exact number was. But we started out with a number that eliminated all the cuts, right? Or excuse me, eliminated all the boosts. Had really only cuts in it. What I found is that on future iterations, I actually got better results in his room with his gear by increasing that reference level. So it's something that you can fiddle with later on, running subsequent optimizations to see what produces the best results for you. So this isn't anything that is set in stone. It's not any super magic number. It doesn't have to be super precise. It's very, very easy to change and run for different values later on. Okay, so we're just going to use 75 decibels as our target line for this particular demo. So that's important because if we go back to our optimization options, again, right click, optimization options, that 75 dB starts to play into account when we start getting into some of these PEQ limits and constraints, okay? So for 75 dB, I'm just gonna put the top of this line, the top of this window at 75 dB to make it a little bit easier for us to see that line. So criteria, again, we mentioned, we set this in our baseline earlier. We could change this here. In my particular config, I'm going to run this example up to 160 hertz. I don't use crossovers much. I don't use very high crossovers. I think Dirac recommends crossovers maybe 85 hertz. I've actually found that I get better results by restricting this window a little bit. I think I end up running from 15 to 130 hertz. Again, these are things that you can play with later on. We're just going to leave this right here. If we go to our PEQ parameter limits, again, we changed this earlier. We want to make sure that our minimum and maximum are the same as our criteria. So I've got that 15 to 160. And now let's talk about our maximum cut. So what we want to do is we want to make sure that it has the ability to cut things appropriately down to our target level. So if our target level is 75, my biggest peak here is right around 105 decibels at about 25 hertz. So 105 dB down to 75 dB is a maximum cut of 30 dB. So we're going to take away this limit and we're going to change this to 30 decibels. Okay. For now, we're going to leave our boost at 0. Okay. And what this is going to do is, and again, this may be more than what the miniDSP is capable of. I think it's plus or minus 16 dB. That's fine. What this is going to do is just make sure that we have a nice cap on what we're cutting on our system. Okay. The next thing that we want to do is we want to globally constrain our maximum cut, because we don't want our PEQ filters to stack on top of one another and end up accidentally cutting something way below that won't really show up until you input things and take a measurement in REW to verify on the outputs after everything's already done. So to do that, we're going to go to the next tab, which is constraints. And under constraints, this is where we can restrict the total amount of boost and the total amount of cut for any given frequency that we have. So we're going to restrict our total PEQ cut, and we just need to make this a little bit larger than that limit that we came up with in this parameter limits field. So if you remember that in this particular config, that's 30 dBs, 105 to 75. So we're just going to make this 31. Okay, and that will keep it from cutting too far and stacking those PEQ filters on top of each other. Okay. We're not going to use a target curve. Talked about that already. Group weights don't apply. So that's all we really need to change for this particular optimization. So if we click OK, we're actually ready to optimize, to do this first kind of optimization run here in our config. Now I'm going to clean things up a little bit. And all I'm going to do is I'm going to close these other graphs that I have open. And the only graph that I want to display, the one I want to be looking at, is this before and after graph. Okay, so what this is going to do is we're going to remember, we're displaying two different configs here. We have our baseline config, which is this top set of traces. And then we have our config that we're going to optimize, and that's this offset set of traces that are a little bit lower. So when I start to optimize this, we're going to start seeing this bottom line here dance around as the optimization runs. It's actually kind of fun to watch. So let's go ahead and kick that off. On the left-hand side, there's a couple of different ways that you can actually kick off an optimization. I personally prefer, I usually right-click, and the top option is Optimize Config. That will start it. Another option is if you hit the little Start Optimization button here at the top, it'll let you select the one that you want to optimize. I have kind of screwed things up before and accidentally started optimizing the wrong thing and not realized it. So my own personal habit has become just to right click on the one that I want to run, and then we'll go ahead and say optimize configuration, and we'll go ahead and we'll start this. So we can see that our optimization is already started. And what's happening is MSO is now you can you can find all the technical details on Andy's website. He's done a really good job explaining what's going on in the background. But it is essentially running some complex math in the background, and it's brute forcing the different combinations of all of these parametric EQ, gain, and delay blocks for each of our subs, trying to get the flattest response. So how do we know that it's improving? Well, if you look down here at the bottom, you see this working and elapsed time, and you see this thing displayed, this error number that's displayed in decibels. This is essentially to simplify it, it's essentially a standard deviation, and it's showing us how much the resulting measurements deviate from a perfect response. And in this case, 0 means there's no deviation. 0 means that my main listening position would be completely perfectly flat. And my, we'll get into performance metrics here in a little bit. 0 for the main listening position will be perfectly flat. 0 for another listening position for the non-MLPs will be perfectly flat. And then there's another one that represents how much the non-listening positions deviate from the MLP as well. And if that were 0, you'd have like basically 3 straight overlapping lines, okay? The thing that's important to remember is really the lower this error number is, the better the results are. So we're just going to let this churn. You can see this has only been running for 1.8 minutes, so it's been running for less than 2 minutes, and that's already got a pretty smart looking graph there for our MLP. We can see we still have some swings in our non-MLP positions, but remember the scale on this is only at like 2 decibels per line, right? So we're in a home theater environment for amateurs like ourselves, plus or minus 5 dB is considered pretty darn good. So we're getting some pretty good results here just a few minutes in. I can see that my main listening position is probably plus or minus 2.5 dB. And then I've got some bigger swings in the non-listening positions, going down. Right now it's about 4 to 6 dB dips in some of these different areas. So I'm gonna pause the recording here for a few minutes. I'm going to let this run for that full 20 minutes, and we'll kind of see what we get. As I mentioned earlier, I guess while we're letting this run for a little bit, one more comment on the optimization is this is very CPU dependent. We're brute forcing things. We're running a lot of different calculations in the background. So the more CPUs you give it, the faster you get results. Potentially, in theory, you should get faster results. If you have a slower machine, or if you don't have as many CPUs available, the longer you let it run, you can get equivalent results. But if you're running it on a smaller machine or a bigger machine, you're going to get results maybe faster or slower than what we have here. By default, I think MSO will use up to 80% of the processing power of the machine that's available. So, and I think there's a setting for that to tell it to behave or to use everything it can get. So we'll pause now, and we'll let this run, and we'll come back here in just a little bit. Okay, so this optimization we can see is still running. I don't want this to take all day long because I'm going to run a couple other optimizations as part of this. So I'm going to manually stop this when it hits to 10 minutes. It's also good to know that you can manually stop these optimizations when they're running. So if you go here in the top left, you'll see this little square, just like stopping on a movie or what have you. And then when this hits 10, or close enough to 10, which is probably about now, if you go ahead and hit stop, it'll say, hey, do you want to accept the results of optimizing this particular config? If you say no, it basically resets everything to what it was when it started. In that case, it would go back to looking like the graph beforehand. But we want to go ahead and accept it. We think this is pretty good. So we're going to say yes. So now we have an optimized config. And those are pretty darn good results, right? I think one of the biggest things to remember about MSO is that we're not just optimizing the main listening position. And that's really the biggest value that MSO brings. When I first got started in this, I think like most folks, I was using REW. And REW and that optimization method and doing your EQ over there and just bringing that into the miniDSP is really, really good if you've only got one listening position. And frankly, MSO probably is not appropriate if you only have a single listening position. Just use the REW method that everybody's been using for quite a while and everybody talks about. But what's really interesting and really powerful with MSO is that we're also optimizing our non-main listening position. So we can see here that we've got really good response at all of our listening positions compared to our before graph, right? So this is pretty nice. We can see that there's some stuff that we don't really like. I typically focus pretty heavily on the crossover region and performance in the crossover region when I look at these graphs. That crossover region is going to vary for folks, but I would say that the most common range is probably anywhere from 50 to maybe 110 or 120 hertz, just depending on what your main speakers are and maybe what your satellites are and how low they can play. So if I look at that particular area, I can see here between 50 and 60 hertz. We've still got some pretty big deviations in our non-main listening position seats. Remember, we optimized for 75 dB, but we're offset by 10. So the target line for this is 65 dB. And if we look at that, we've still got some bigger dips than I would really like to see. Remember I said earlier, plus or minus 5 dB is really a great target for us. And we're kind of outside that, right? We're about right at 5 dB, maybe a hair below for the left position, and we're getting close to 7 decibels down in the right position, which I don't really like. But overall, this is really, really good. So the next question becomes, well, what should I look at changing to make this optimization look even better? How do I clean this particular area up? Or some of your optimizations might show some really weird stuff starting to happen. Maybe you only optimize up to 100 hertz, but right after 100 hertz, things really go haywire. In my room, things kind of trail off. Frankly, they trail off pretty nicely going up to that 200 hertz range. So I'm not really concerned about that. But maybe you have a big null that shows up, or some just really weird divergent behavior that's a little bit too close to your crossover range. So let's look at some options for kind of fiddling with this and improving the way that this looks. So to do that, we don't want to change the current config that we have. We want to operate on a new config. Remember, a configuration is basically an experiment that you're going to run to see what to see what looks best in your room. So the first thing we want to do is, if we kind of minimize this on the left-hand side, again, we're in the config view, and we've got this 75 dB config that we just ran. So what I want to do is I want to run with the same exact parameters for the most part. But we're going to experiment by adding a couple of additional PEQ filters to see if we can shore this up, okay? So the easiest thing to do is right-click on this config that we just ran, and let's clone this configuration into a new one. We're going to call this, let's call this 75 dB. We're still going to optimize from 15 to 160 hertz. But maybe this time let's go with, I don't know, let's say 8 PEQ filters. All right, so that's why I'm going to call this 75 dB, which is my target. That's my optimization range. And then we're just going to say, hey, this is going to be 8 PEQ filters. We're going to go ahead and clone any associated graphs. So let's say, okay. You can see I've now got a config that's called 8 PEQ filters, right? So let's go back to our data view, because the first thing we need to do is clean up graphs. And we need to get something that we can actually look at while this thing is running. So we can see I've got my baseline listening positions, my original listening positions, my before and after, and now I have 2 additional graphs. I've got a listening positions graph and I've got a before and after graph. So let's rename this one here. So we'll rename this one. This is going to be my 8 PEQ listening positions. And then this one, we're going to end up using this one to compare all 3 of them together. So I'm going to rename this one, and I'm going to call this bass verse 5 PEQ verse 8 PEQ. So this graph we're going to use to show all of our different charts, all of our different traces all in the same graph. So we've renamed them here, so that'll get the tabs for us. But now what we need to do is we need to change the names on the graphs themselves. So if you right-click on a graph and go to Graph Properties, this is going to be the 8 PEQ. So let's change that to 8. That's the only thing that we need to change. And on this one, we're going to right-click Graph Properties. We're going to change a couple of different things. The first thing that we're going to do is we're going to change this to the bass verse 5 PEQ versus 8 PEQ. That's going to change our title that shows up here where it says before and after right now. So we'll go ahead and we'll say apply. The next thing we need to do is we need to make sure that we have all of our data. So if we go down to data and we go to measurement groups, by default, it keeps the baseline and then it adds our 8 PEQ, our 8 PEQ bill of ads. It basically changes from the original config to the new config, okay? This can get a little bit confusing, so let me show you the way that I personally do this to keep me sane when I'm working with all of these graphs. We're not going to change anything here just yet. The first thing that we're going to do is we're going to go over to our new graph, and let's go ahead and show this graph. And this graph is going to look the same as our other graph, okay? What we want to do is make sure that we've got all of our traces still named the correct names. The problem we've got is these names aren't going to match what our new config is called. Remember, our new config is called 8 PEQ. And if I expand this 5 PEQ, notice it's actually referring to the 8 PEQ config group that we have. So I want to go ahead and rename these to the 8 PEQ. So if we right click, rename it, let's just change that to an 8. Right click, rename it. We'll change that to an 8. Right click, rename it. And we'll change this guy to an 8. So this is now going to show our before and after for baseline and 8 PEQ. Now what we want to do is we want to add in our 5 PEQ results. So if I go back to the top of this particular graph, right click on it, graph properties, data, measurement groups, let's go ahead and select the 5 PEQ as well. So we'll go ahead and hit apply and say okay. And notice we've got a 5 PEQ graph in there. Now, why did that pop up here instead of down here at the bottom or up here at the top? That's our 5 PEQ measurement. Remember, we optimized to a 75 dB target level. That is the optimization at the 75 dB target level. That's not configured to have any offset. The offset followed our original 8 PEQ or the new 8 PEQ when we cloned the graph. So that's actually okay. We can still run this, we can rerun this using the same settings, and we don't have to go and mess with the data offset for these new traces that we're displaying. But what we do need to change is, again, notice down here at the bottom in the legend, it's measurement group trace 7, 8, and 9. We want to change those and make those meaningful. So let's go in here. We did this earlier. We're going to select our measurement trace. We're going to say rename, and this is our 5 PEQ left. This will be our 5 PEQ MLP, if I can learn how to type. And this last one's going to be our 5 PEQ right. So now my legend matches the data that is actually shown on the graph here. So what do we need to do now? Well, part of the problem that we have, as you can see, is that our new 8 PEQ data here down at the bottom has already been optimized, and that's a problem. So when we go to our config view, what does it mean why does it show as already optimized? Well, when we cloned this, not only did we clone the data that it was traced, but we actually cloned after our optimization was run. So we cloned with all of the parametric EQ, gain, and delay settings that were associated with this. So if I go into my 5 PEQ and I select one of these filters, so I'm just going to go to this left front sub and I'm going to select this first FL1 filter. You notice on the right hand side we can see the properties of this filter. So this is a PEQ filter. PEQs have 3 values. They have the center frequency, which is the midpoint of where the filter is going to take effect. They have a boost value. Boost is a little bit of a misnomer. It's actually a gain. And the gain can be a positive or a negative value to represent a cut. Here we can see that this has a value, a cut of minus 9.8 dB at the center frequency value of 127.9 hertz. Okay. The last parameter a PEQ has is the Q, which is essentially a measure of the bandwidth, or how wide of an area of frequency that this particular PEQ impacts. So we can see it's got a Q of 8.3. If I flip back to my 8 PEQ and I look at the same exact filter, it's got the same exact values. Okay. We don't want to optimize something that's already been optimized. Fortunately, MSO gives us a nice clean way to reset everything so that we can have another go at it. So if I right click on this, down at the bottom, near the bottom, there's a reset all filter parameter values. If we go ahead and click on that, it says, hey, you're going to reset everything. You sure you want to do it? I can't undo it. Say yes. We're going to see this bottom one snap and now match all of our originals. And again, this one has that offset in it. That's why it appears down kind of low. So that when we optimize for 75, it'll actually end up settling down here around that 65 because it has that minus 10 dB offset that we had earlier. So now what we need to do is we actually need to tell it, hey, we've got more, I want you to use more PEQ filters. So what we need to do is we need to add some filters to each one of our output channels so that MSO can use those to run the optimization. When we initially did our import, we said use 5. So the easiest way to add 3 more is to select one of these. We can right click on it. We can say copy. And then if we select the filters folder, we can actually, right click and we can paste. If you're a keyboard person, you can use Control V. I'll do it with the GUI the first time. Control V, paste, paste. So I've now pasted 3 additional PEQ filters. So now I have a total of 8 for my left front sub. I need the same thing for all my other subs. So I'm just going to use the keyboard shortcut since that's a little bit faster. I'm going to paste 3 more for each one of my other subs. There's 1, 2, 3. 1, 2, 3. Whoops, got to select filters. 1, 2, 3. 1, 2, 3. So now I have 8 PEQs for each of my sub filters, plus my gain blocks, plus my delay blocks. Now, if you remember correctly, we set some options to restrict our PEQs to make sure that we're not going to overcut, to make sure that they're centered and things of that nature. So what we want to do is we want to double check and make sure that those things are all still set correctly. So if I click on my 8 PEQ config, optimization options, I can double check everything before I run it. Hey, 75 dB, 15 to 160. I'm going to change this to 10 minutes. 20 was too long because, like I said, I don't want to spend all day doing this. You can make that whatever you want it to be. Our parameter limits, everything is still 15 to 160. That max cut is still 30. Boost is still 0. If I go to my constraints, it's still 31. We're good to go. We're ready to run this optimization. So I'm going to go ahead and run this optimization, and we'll see what kind of results we get. So if we right click optimize config on our 8 PEQ, there we go. We're off to the races, and we get to see nice, fun dancing lines as this thing goes off and figures itself out. I'll pause the recording. We'll come back here in about 10 minutes. All right, so that ran for about 10 minutes, exactly 10 minutes actually, and we're done. So we're gonna go ahead and we're gonna accept the results of this one. We're gonna say yes. We're gonna take a look at what happened. So, all right, so if I look at this graph, again, we're eyeballing things right now. I'll show you how to get some real data and get really, really detailed on which one is better. But if we can look at this, like they're pretty similar, you know, from 15 hertz up to about 50 hertz. Just eyeballing it, the 8 PEQs looks a little bit better down flat, or a little bit better flat, excuse me, looks a little better down low, a little bit flatter, a little bit smoother response in all the listening positions. But critically, that area that we were kind of concerned about between 50 and 60 hertz, it looks a lot better. We've still got a little bit of deviation here, but remember our scale here is 2 dB. We're centered on 65 dB. So we're pretty much plus or minus 3 dB through this area where we're getting some 5 and 7 dB dips. Now where this particular optimization gets a little bit more wonky is a little bit higher. We can see that we've got a little bit more of a deviation, probably up in the 120-ish hertz range. We've got a little bit more, few more swings out here maybe than we had compared to the previous one. But again, looking at that 65 dB level that we were targeting, we're still pretty much plus or minus 3 dB through this whole region. So overall, it's a lot better result. So I personally, maybe I'm happy with this, maybe I'm not. So I mentioned earlier, we walked through an example of how to add additional PEQs. The miniDSP 2x4 HD has up to 10 PEQs, so I could go in and add 2 more PEQs per output filter if I wanted to really play with that and see if that really bought me anything. Some other things to consider as you try to run additional optimizations and get a nice even sub response is, again, I mentioned we can change that target curve. Maybe you try it a little bit higher. Some of these things, these dips that we have here, are products of just natural cancellation from unaligned subs. So the delays are going to fix some of these things naturally. So even though 75 dB came in below all the big dips, maybe 80 dB is a better target for this. Maybe even 85 dB, just kind of picking some numbers out that are nice and round numbers that you might want to experiment with. One of the other things that we did not get into in this either is you can add, there's this concept of shared filters in MSO, and a shared filter is a filter or a PEQ that goes on the input side of your miniDSP. So you can actually add input filters and use those to also help flatten out your overall sub response. There's some pretty interesting results that you get when you add those input filters that actually can help you get a really, really flat response if that's just something that you're after. Depending on your use case, you may or may not want to do that. Like personally, I use bass EQ or BEQ as most people call us. So I don't like to have any filters on the input side of my DSP. I haven't gotten into BEQ Designer and merging my own settings with BEQ. I avoid that myself. Another reason I avoid that is because frankly, I've gotten really, really good results in my room just using the output side filters and output side gains and delays. So we'll jump into next is how do you really quantitatively look at the differences, because you're going to end up in a situation where you just can't eyeball it. They're so close, you can't tell which one's better, which one's worse. So next we're going to drop into the performance metrics and take a look at how we can actually look at some hard numbers to compare a couple of these different configs. Okay, let's jump into the performance metrics. So performance metrics give us some numbers that we can use to compare different configurations. If you right click on one of your configs on the left-hand side, I'm going to start with the 5 PEQ filter. The third option down is going to be performance metrics. So let's go ahead and click on the performance metrics, and it's going to pop up this little window for us. And this is our kind of our basis for comparison that we're going to use for all of our different configs. And we'll walk through what each one of these sets of numbers means and which ones you really want to pay attention to. So here we can see there's 3 numbers on the right-hand side that we really want to care about. And those are the MLP target error, the seat-to-seat variation, and then the final error. And these are all essentially, the easiest way to think about it is standard deviation. All right, so lower is better. So we're looking at the 5 PEQ number. And we're using the entire frequency range of the config. So we're looking at this whole 15 to 160 hertz. And we can see that our main listening position target error is 0.82. Our seat to seat variation is a little bit better, so they don't vary quite as much. This is a measure of how much they vary from the MLP, so they track pretty well at 0.76. And then the final error is a combination of these two. It looks like it's an average, or it might be an average. It's actually not. It's a little bit of a weighted average. It's probably more complicated than that, and Andy probably will cringe when he hears me say that. But it's essentially a combination of these two different metrics, and these are the three that I really look at and that I really pay attention to when I'm starting to kind of compare a couple of different optimizations. So I'm going to do real quick. So I'm going to open up I'm going to go back into a text editor here, and I'm going to kick open a new file. Because what I want to do, let's do new file. What I want to do is I want to jot some of these numbers down for each one of my configs. So this first one that we're looking at is our 5 PEQ config. This is 5 PEQs, and this is from 15 to 160 hertz. And then we're going to look at a couple of different ranges. And these are things that I just look at. The stuff that you care about might be a little bit different. But I tend to look at the total overall number. I tend to look at the low frequency response. So I'll look at that 15 to 50 hertz range. And then I tend to look at that crossover range as well. So I'll look at 50 hertz up to 120 hertz, which is, that's that really critical crossover range. So let's just jot these numbers down. So my total here is 0.82. This is going to be I could probably put this down here, but these will be MLP. Throw another little tab in here so everything lines up. My MLP, this is going to be my seat to seat, which is going to be 0.76. This is going to be my final, which is going to be 0.78. So that's my overall. So let's go back and take a look at some of these specific ranges. So what we can do is we can use a custom frequency range. So for that lower one, I can change it from 15, I can change this to 50, and I hit recalculate, and it's going to update these numbers. They're going to change. Remember, we're looking for lower numbers. Lower is better, right? So let me jump back over here and jot these down real quick. So my 15 to 50 range is 0.72. I've got 0.46, got 0.54. And again, that next range the one that I really care about as well is what's that crossover range. So that's going to be that 50 to 120 hertz range. 120, and we'll recalculate, and we'll go back and jot these down really quickly. So I've got 0.88, I've got 0.79, and I've got 0.82. So those are the performance metrics. And again, it's rough and tough. It's a standard deviation from perfect, which would be 0. Lower is better. So now we have some really quantitative numbers of how this particular 5 PEQ optimization performed overall from my main listening position, from seat to seat, also in some critical areas that we might really care about, right? The low frequency response, and then also the crossover range. So let's go grab these same numbers for our 8 PEQ. So I'm just gonna copy this, paste this. So it's gonna be an 8 PEQ. Go in and delete all of these so there's no confusion as to what we're looking at, what we're gonna compare. Last one, delete. All right, go back over here. We'll close this. We'll select our 8 PEQ, right click, performance metrics, move this out of the way, and we'll start jotting these numbers down. So for my MLP, I have a 0.86, I have a 0.65, and my final is a 0.71. So let's go grab 15 to 50. Recalculate. So for my MLP, I have a 0.42, my seat to seat 0.40, and then a 0.41 final. Last but never least, my crossover region that I care about, 120, we'll recalculate that. And we've got an MLP of 1.06, 0.78, 0.86. Okay, so now I've got some real metrics that I can look at and really compare between the two. So what matters? Well, frankly, what matters to you? What's the most important to you? So here we can see that overall, my total MLP is not quite as flat. It's 0.86, 0.82, probably an inconsequential difference. They're going to be pretty, you're not going to be able to hear that difference that close. But my seat to seat variation is much, much better at a 0.76 to 0.75. And then my final is also a little bit better at 7.8 to 7.1. Down low, we can see we actually got some pretty big improvements in that 15 to 50 hertz range. The 8 PEQ is a lot lower if we look at these numbers here, kind of in the middle. 0.72 versus 4.2, 4.6, and 54 versus 40 and 41 respectively. But in that crossover region, it doesn't look as good, right? So I got a 0.88, a 0.79, and a 0.82 versus a 1.0, a 0.78, and then a 0.86, which are both pretty close. But that MLP's got a lot more variance in that crossover region. Is that acceptable to you? Maybe it is, maybe it isn't. We're still plus or minus 3 dB, so it looks pretty good to me. But this is one of those examples where it actually does look a little bit worse on the charts. Again, we're still plus or minus 3 dB, but this is an area where, okay, maybe I don't like this. Maybe I run another optimization. Maybe I add in 2 more PEQ filters and get my full 10 PEQs per channel and see if that helps. Maybe I change my target level and I run it up against an 80 dB target level or an 85 dB target level. Just to see if I can get better results. Remember, we also are not allowing, if I go into my optimization options, under my parameter limits, we're allowing 0 boost. So maybe I run that 8 PEQ, but I add 3 dB. I let it boosting by 3 dB isn't such a bad thing. Maybe I let it boost by 3 dB here. I just want to make sure that if I set this to 3, as an example, that I set my constraints and I restrict the total boost to something a little bit larger. I would probably do something like 3.1. I really don't want to boost by a full decibel over. But those are some of the types of things that we can look at and play with to get much, much better results. Okay. So now let's just make an assumption that I think that the 8 PEQ as it is a lot better, and that's what I want to implement. So let's poke around a little bit and see what kind of results that we've got. So for each one of my subs, the first thing I'm going to look at is I'm going to look at delay. Now what you're going to notice is the delay only exists on 3 subs. And if you've never integrated multiple subs before, that might look a little bit weird. It's like, why wouldn't I delay all 4 of them? Well, when I'm integrating subs with one another, the only thing that matters is their relative delays between each other. We're going to go in and our room correction software, Odyssey or Dirac or ARC or whatever we're using, is going to set its own delay when it runs for everything overall when it runs. So we don't have to worry about our delays between our aligned subs and our main system. Room EQ is going to take care of that for us. The other thing is if I have delays on everything, it creates circular logic, and we can't solve when we don't have a fixed reference point for one of our subs. So only one of them only one of them is missing the delay, but all the other ones have that. So if I click on the delays, I can see, hey, I've got a 6 millisecond delay here. I've got a 9 millisecond delay here. And I've got a negative 19. So that's an interesting one. So I've got 2 positive delays and I've got 2 negative, and I got a negative delay. That's kind of a problem. because most DSPs, mini DSP included, can't really handle, making something faster, right? We can slow things down, we can't make it faster. Fortunately, there is a nice feature here in MSO that will let us normalize that. So if I right click over here on my subwoofer channels, there's an option down here for normalizing my delays. So I want to go ahead and normalize my delays. So we're going to click that button, and it says, hey, we're going to make some changes. Remember, we had some limitations. There were some limitations on delays. It's increased that. This is not a problem in the miniDSP 2.4 HD. It may be a problem in the non-HD versions. I think one of the limitations there is it doesn't have the delay range that we get from that's available in the HD. So if we close that down and we go back and look at our delays, it moved our delay blocks around. So now this first sub has no delay block, but if I click my delays here, we can see we've got a 28 millisecond delay, a 25 millisecond, almost 26 millisecond delay, and then our last one's a 19 millisecond delay. So now we can see our delays are all something that we can go in and input into a mini DSP. Gains, we see our gains, 11.5, minus 15, minus 10, and minus 12. So it's cutting our delays. The reason the cuts are so big is because we have specified that 75 dB target line. If we increase our 75 dB target line to something like 80 or 85 dB, these gain values are going to get they're not going to cut as much, right? There's not going to be as much gain cut out of our subs. If I'm eyeballing this gain, that's minus 12, minus 10, minus 15, which is a max, and then a minus 11. I would be really comfortable moving this up at least 5, if not maybe 10 decibels, and then running another optimization to see what kind of results I get, again, because it's cut my gains quite a bit. That means I'm giving up potential output for my subs. I would probably go ahead and rerun this at like an 80 and then an 85 to see what kind of gains I get, and then to see what my curve looks like. And then again, we can go look. I'm not going to go through every PEQ, but here's an example of one. Hey, this is right at our max of 160 hertz. It's a 3.4 dB cut, and it's got a Q of 1.679. So this is great. So we've got kind of all these different things that we want to look at. So the last thing that we want to do here is let's figure out how we put this into our mini DSP. So if I go up here to the subwoofer channels and I right click on this, oops, not there, sorry, on my config, right click on my config, I can run this show filter report. So let's go ahead and run our filter report and let's see what that looks like. So here we can see our performance metrics our filter report for this particular config. It's got the name of the config at the top. You can see that in the tab name. A lot of information in here, a lot of raw output. We just want to scroll all the way to the bottom. This is the stuff that we really care about. So there's two main sections that we're looking at here. The first one is concerned with, we've got raw and final gains and delays for everything here. There's going to be a couple of different options, and I'll kind of walk through each one of these to show you what they look like. The top section here is the uncorrected or the raw delays. These are what we saw in the filters itself, okay? So here we can see those same numbers, the minus 10, 12, 15, and 11 that we saw for the gains. And here we can see those delays that are unadjusted as well. The ones that we're going to use, though, are going to come from one of these three blocks down here. They're going to come from these three blocks down here. The top two blocks are our gain settings, okay? So there's two sections to this set of gains. The first set of gains it makes use of your subwoofer out trim setting on your AVR. So I mentioned earlier, hey, maybe I rerun this at a higher level in order to see if I get better results and to get those gains kind of moved up. This kind of simplifies things for us if we want to use it as is, because what we can do is we can go in and we can drop our trim gain and our sub by 10 dB, and then we would use these values in our miniDSP for each one of our subs. What I personally do, and again, this is me in my room, is I really end up ignoring all of those gain settings that are in that initial report, and I always use the minimal gain settings. The reason I use minimal gain settings is because I'm going to use my particular room EQ solution to set all my gains and trims after the fact. So I'm not going to go in and fiddle with the sub trim in my AVR. I mentioned earlier, I use Dirac. I also use Dirac's Live Bass Control, DLBC, to handle the integration of my sub with the rest of my speakers. Frankly, it does a whole hell of a lot better job than I could if I were setting this stuff manually. So I tend to use the minimal gain settings, and then I also let my room correction handle that. That keeps us from cutting things way too much. For using room correction, like Odyssey, I'm not an Odyssey expert, but I've seen enough on the threads where there are some very specific trim settings that you're trying to target for Odyssey to make sure that it's got a good level. Dirac, if you follow the guide that I think it's Marcus767 has posted it on the official Dirac Live thread over on AVS forums, they recommend in that guide, hey, you want your sub to be a few dB hotter than the rest of your system. So we take care of all of that in our room correction. So that's where I tend to use the minimal gain settings in my own config. And then these are our delay settings here, and these will go straight into the miniDSP, okay? So I'll just copy pasta this stuff down. Refresh it. I'll copy it out, stick it in a text file, and then I'll use that to input into my miniDSP. So the other thing that we need to worry about is we need to get our PEQ filters into our miniDSP. I'm going to tell you right now, you don't want to enter any of this crap manually. It's a pain in the butt. It'll take you forever. It's super error prone. Thankfully, between MSO and miniDSP, there's a really nice, easy way to export our filter settings for each of our subs and to import those directly into our miniDSP. So now that we have our gains and delays, what we want to do is we want to export our filters. So on the left-hand side, I'm going to go ahead and we'll leave this open. If we select, this is the subwoofer channels here on the left, my left front, this is my first sub, and these filter settings. Ooh, I actually forgot. We need to make sure that we're using the right export settings. Let's go do that first. So for those of you that don't know, there are some specific filter settings that need to be done for the miniDSP or for non-miniDSP units. Not every single DSP out there has the same settings. I'm using this for miniDSP. This is what I have in my home theater, what most people use. So we're going to go ahead and set it up for that. If we go to Tools and we go to Application Options, we're going to go down here to Hardware. And this is where we actually can set up our miniDSP export, right? I don't remember the defaults for this in the new version. I know I've made some changes here, so these may have been changed based from the defaults. But what we want to do is let's ignore this top section for now. We're going to concentrate on this bottom section. On this bottom section here, if this is not enabled, let's enable miniDSP specific biquad reporting and file export. We want to make sure that we use 96 kilohertz for the miniDSP 2x4 HD. And then we can make sure that, I believe these were updated to be 10 and 10. And we want to make sure that these match as well. So this is going to get our files in the proper format to be imported successfully into the miniDSP. If you have the wrong sample rate, it's still going to export just fine, but the the resulting PEQ filters are not going to be what you expect, and the results are not going to be anywhere close to what was shown in MSO. So that's what we have there. If you are going to make use of your AVR's trim feature, this is where you want to say, hey, yeah, I've got an AVR with pre-pro and sub out. Every AVR is a little bit different. I have a JBL SDP55. If I was doing this manually, it uses meters, and it has a half a dB is the minimum gain change, and 0.01 meters is the smallest sub increment. I think my Yamaha, if I remember correctly, used feet. It was also a half a dB, but I don't remember. Like, it may have been 1 or 2 feet difference. So you'd have to make sure that you adjust this for whatever's appropriate for your AVR. So let's make sure that that's set, particularly on the miniDSP side of things. So we'll say, okay, now we're ready to actually export our filters. So again, subwoofer channel. This particular config is what we're looking at. It's the one I want. Sub channels. You know, my first sub here. We're going to go to filters. We're going to right click, and we're going to say save miniDSP biquad text for this channel. When we do that, we're going to get a window that pops up, and it's going to be a location for where we want to save this. I'm going to make a new folder. So I'm going to right click. I'm going to say new folder, and I'm going to call this my 8 PEQ miniDSP filters. I'll just even call this channel filters. I'm going to go into that. This was for my left front sub, so I want to call this I want to make sure I keep this stuff straight, so I'm going to call this my left front filters. You can call it whatever you want. Just make sure you can keep track of which filters belong to which sub. If you put the wrong filters on the wrong sub, you're not going to get the results that you expect. So we'll save that. Again, we're just going to repeat this for each one. So this is my left rear filters. It's my right front filters. Last and never least, my right rear filters. So we're pretty much done. We know what our gains and delays need to be set on the miniDSP. We have all of our filter files exported and ready for use on our miniDSP. Last thing I want to do is I want to go ahead and save this. So I'm going to say File, Save, and we're going to save this project, and we're going to call this, I'm going to put it over here. I'm going to call this the MSO tutorial video project. So we'll save that guy. That way we can come back to it. We can open it up. We've got something that's repeatable that we can refer back to, run additional configs without having to make any other measurements, without having to go and fiddle with settings. We can kind of come in here and tweak to our heart's content until we get a curve that we like. So next, we're going to pop over to the miniDSP, and I'm going to show you how to import all these things into the miniDSP. Okay, so here we are. We're getting ready to import our miniDSP settings and filters that we created in MSO into the miniDSP. So I've got a couple of things open on the screen here. The first one on the left is the text from our gains and delays and the filter report that we just looked at. And on the right-hand side, I've got the miniDSP plugin loaded and connected into my miniDSP. One thing, this config, you can see I've got no PEQs on anything here. If I look, no crossovers, everything's bypassed. My PEQs are flat for everything. One of the things that most people don't realize, because it's not the most intuitive thing, it's super helpful as well for miniDSP users. You can rename these things. So like this input here, that's my input coming from my receiver. I know how I have my subs hooked up over here, so I could rename these guys if I go to the output tab here at the top, I can rename them as well. So for example, I know that's my left front. That's my right front. That's my left rear. That's my right rear. This is going to make importing things a little bit easier. So I suggest you go in and rename it. It'll also bring it over here so you can check your routing out, make sure that's all set. But here we're set up to go. So the first thing we need to do is get our gains and our delays in. So gains and delays, all of this stuff is all implemented on the output side. So we're going to click the output button, which is right below config 1. We can see we've got our 4 channels here. So again, because we named everything appropriately, this is going to be pretty easy for us to go ahead and implement. So in this config, my left front is a minus 2.3. So I'm going to do minus 2.3. My right front is 0, or excuse me, my left rear is 0, which is this one. My right, see how it gets confusing if you don't have this stuff set up the right way. My right front is minus 4.94. miniDSP only allows one decimal place, so that's one reason that you're going to see some small variation between your verification metrics and verification measurements in REW and what you would see within the traces in MSO. The other variations that you might see in the measurements are mic positioning. If your mic is not in the exact same position, which it never is unless you took your measurements and left it while you're making these changes, you will see a little bit of a variance. So not unexpected. But anyway, so again, only 2 significant digits. I just enter it in and let it do the rounding for me. But again, my left rear is 0, and then my right rear is a minus 1.78. It takes that and rounds it for me again. So let's just let it do the rounding. Then the last bit that we need to enter in manually is the delays. So my left front is 0. My left rear is 28.61. My right front is 25.98, and my right rear is 19.60. So I have all of my gains and delays entered in into my subs. So the last thing that I need to do is I need to get my filters in place. So the filters are pretty straightforward. What we're going to do is you see the filters here. I've got the files, but we don't need to worry about all of this. Like we don't have to type that in. We don't even have to copy paste it, which is going to be error prone. What we're going to do is we're going to use the import feature under the advanced PEQ settings of the miniDSP. So let me go ahead and stop sharing this guy, and let's just concentrate on our miniDSP config. I'll make this a little bit bigger for you. So what we're going to do now is we're going to start with our left front sub. So we're going to click on PEQ, and it's going to bring up our equalizer settings. So you can set these in a basic mode, which is the default, or you can set these in an advanced mode. In the basic mode, you'd come in and you would manually enter the frequency, the gain, and the Q for each of these filters. You would have to do that up to 10 times, depending on how many of these that you implemented. Again, MSO, miniDSP, make this easy on us. So what we're going to do is we're going to go into advanced mode. In advanced mode, there's this import button over here. So if I click import, it's going to bring up a pop-up window. Let me make sure that you guys can see that pop-up window. And you may have to browse around and find exactly where you save these files. I opened it earlier just so it'd be a little bit easier. But I know I'm on my left front sub, so I'm going to click my left front filter. I'm going to say open. That's going to go away. Let me hide my import thing again, and we can see, hey, I've got some PEQs on this guy. Sweet. So we want to repeat that setting for each of our other channels. So we'll go ahead and close this. We'll go to the right front PEQ. Just click to advanced mode. Select import. Select right front for me. Whatever you called your sub, call your sub. Or find your sub, we'll import it. We've got PEQs. We'll close that one, and we're going to repeat this for each sub. Advanced, import. Which one am I doing? I forgot which one I'm doing. Hang on a second. Left rear. Left rear. Finally, the right rear. And now I've got all my PEQs. I close that. Everything is done and ready to be measured in your room for verification. It's actually really simple to get these things in here. Again, I'll probably do another video at some point on how to take the measurements for use with MSO. I would want to take my verification measurements the same way, and we'll go through that later, and I'll get you the details on that. Again, I mentioned earlier, you're going to see a little bit of variance. You've got a single decimal place versus 2 decimal places in MSO. Then your mic has to be in the exact same perfect position to get things that you compare, which basically never happens. I even will use a 2-plane laser level to make sure I get things in a pretty consistent place, but there's always some kind of a variation between them. So you're all set, you're all ready to go. Run your room correction software and enjoy. We'll hopefully see you in the next video. Thanks.